Now we have Martin, also known as Leyrer. He'll be talking about Modern Command Line Tools version 1.4. Thank you.
You're clapping now. Let's see how this ends. Thank you very much. Good morning. I'm surprised to see so many people in this room. Thank you very much for showing up. I hope I will make it worth your time. Just to make sure, are you in the right room? This is Modern Command Line Tools, and my clicker just, yeah. The next talks will be towards a perfect cryptocurrency wallet in Tesla in about 14 minutes. And also in the hackerspace area, there will be the Things Network Novi Sad. I would go there because that's a lot more interesting than the old Leyrer. This is Modern Command Line Tools. This is version 1.4. So there's new content compared to the German talks I gave earlier this year. This is the first time I'm giving this talk in English. So I hope I have eradicated all German words. If not, please do not hang me for that. I will fix the slides later on. If you want to Twitter or Mastodon or whatever about it, the hashtag would be Balkan2K18. My name is Leyrer or Martin or Hey You or whatever. If you have a question, please interrupt me. But before you ask your question, please wait for the microphone so we get the question for the recording as well. Speaking of recordings, just to make it clear, I'm happy for you to tweet, take pictures, do whatever with the content. The slides will be available. All the links will be available on the Balkan website as well as on my homepage. The address for my homepage will be at the end of the slides. Oh, he's pinging around for the room. Awesome, thank you. No, it's fine, no worries. So, let's start with the why. Why in the world do I want to talk about modern command line tools and what are modern command line tools, and what did I think about when I did this talk? Well, the thing is, I'm an old guy. I'm used to do things in a special way, in a certain way, and Douglas Adams actually postulated 3 axioms that very nicely describe the problem I'm facing currently. So Douglas Adams, the author of The Hitchhiker's Guide to the Galaxy, actually said that anything in this world when you are born is normal and ordinary, and it's just natural part of the way the world works, right? So for a lot of you, as I see, the internet is just there. It was always there since you can think. Anything that is invented between when you're 15 and 35 is new and exciting and revolutionary, and you can probably get a career in it. So for me, that was IT and internet and all that thing. But, and that's the catch, anything invented after you're 35 is against the natural order of things. And so, as you can probably guess, I'm a little bit older than 35, so things like Docker or Kubernetes and all that weird stuff, it's basically, I don't like that. So, but I also don't like to be in a rut to do everything the same way all over again. So I sat down and said, okay, how can I actually improve the way I work on the command line? Are there any new tools I haven't seen, I haven't thought about, I haven't dreamed about that are actually there and could improve my work or my time on the computer? So also this talk is not intended to force you to use all the tools I'm showing you. It's just to give you an idea of what's out there. Maybe you find a tool or two that you incorporate in your daily work. But if you don't, that's fine. If you have a tool I haven't covered, please let me know during Q&A maybe. But if you find something that is of interest to you, I'm very happy and glad, and I'm also very happy on feedback, either positive or negative, through Twitter, or if you buy me a drink afterwards or whatever. So the plan for this is short history on command line tools, and then we will dig into systemd and dig and trace path and IP route and all the other stuff. And it's not only slideware, I also have quite a few demos for you prepared. Let's see how this works. It worked in the morning, so let's see. So you probably have seen this before. Basically all the command line tools we use in everyday work inherited from the Unix tree of operating systems. So from the old system 1 to 4, system 5, the stuff that ran on a PDP-11, PDP-10, and Solaris and whatever. So this is where our command lines come from. And for example, the grep command you all use, exists since 1973. Yeah, so I'm a little bit older than that, but just a little bit. And the nice thing about the Unix philosophy is that the commands are as simple as possible and that you can chain them together, but I will get into that in a little bit more detail. So this is Unix, and we all know Unix. Yeah? We all know how to use this. And if you haven't seen that movie, do watch it. It's hilarious. So the Unix philosophy, it was originally coined by McIlroy in '78, and Doug McIlroy basically invented Unix pipelines, spell, diff, sort, join, trough, and a few other tools you probably have seen before. And he postulated the Unix philosophy that basically says, make each program do one thing and one thing only well, and build it afresh instead of adding new features. Sounds familiar? Also expect the output of every program to become the input of another, so you can chain programs together. Don't clutter the output. Keep the output clear and simple and text-based. No binary input or output formats. Don't insist on interactive input. Design and build software to be tried early and often, and also don't be afraid to throw it away and rebuild it. And lastly, use tools in preference to unskilled help. So write code instead of just doing manual labor, even if it's just a simple task. Peter Sellers in 1994 rephrased that to write programs that do one thing and do it well, write programs that work together, and write programs to handle text streams because it's a universal interface, which is awesome, which basically gave us the tools we're using since the 70s. But simple does not mean not complex. So with a lot of simple tools, you can do a lot of complex tasks, and actually can do a lot of interesting work. Keep these Unix philosophy things in mind. We will come to them a little bit later on. So where do all these simple programs actually come from? Well, there is the single Unix specification that all the operating systems that want to use Unix in the name have to adhere to. So that are the usual suspects like AIX and Mac OS and Solaris and all the others. But very few operating systems actually do go through the complete certification for this. But usually they do. One part of that specification, also the POSIX standard, which I will cover in a second. So part of that specification of the single Unix specification is the IEEE standard 1003.1/2008, which basically lists 161 commands that have to be there if you want to call your operating system Unix. So there is actually a lot of stuff you can do a talk about next year if you want to. So take any of these and do a talk. There is also POSIX, or PHASIX as it should be called, but I'm still calling it POSIX. And it's the Portable Operating System Interface. It's specified by the IEEE, the Institute for Electrical and Electronics Engineers. And that standard emerged from a project that began in about 1985, coined by Richard Stallman, which I think a few of you know, at least by name. The interesting stuff with POSIX is that you have to just comply to any of those three lines, so either the API, the command line shell, or the utility interfaces to call yourself POSIX compatible. That's why, for example, Windows NT 4.0 was POSIX compatible because it supplied the API but no commands. Well, of course, there's also the Linux standard base, based on the single Unix specification and based on POSIX. doing the same thing for Linux, and the Linux standard space, of course, also defines a lot of commands and utilities. Again, there's a lot of stuff you can do a talk about next year, so I don't have to do one. Then, of course, there is the util Linux standard package that's distributed by the Linux kernel organization. That also supplies a lot of commands I'm not going to talk about today. And of course, if you're using a GNU-based system, the GNU core utilities that have to be in every operating system that call itself GNU. So I'm also not going to talk about those tools. I'm also not going to talk about tools that need a server running on your system. Because I think that's just strange. And, what do I mean by this? I mean by this Java-based search engine where you write a Ruby client with a command line that is like 120 characters to get the man pages for a command. And for that, you have to run a Java-based server on your laptop. There are easier ways to do that. There's either man-k, or there's apropos to actually do the same thing without Java, without a server, and without writing 120 character command lines. So what I'm talking about, for example, on systemd. Systemd replaced the Unix system 5 init scripts, or tries to, or already did for most of the operating systems we are handling with Linux. Used to create fun issues with tmux and a few other tools, and basically broke a lot of stuff. I'm not a fan of systemd, but we have to live with it. So a little helper here, old and tired is etc init tool start. Now we have to use system control, start tool, stop tool, restart tool, or status tool, which is okay. So let's compare, for example, how do you get the status out of Apache? In the old days, we used Apache 2 status and got back Apache 2's running. With systemd, of course, which adheres to the whole Unix command line philosophy, etc., has a concise, easy to read, easy to parse output that is restricted to the essential info. Have you found the line where it says if Apache is running or not yet? So, yeah. But of course, there are also a few upsides of systemd. Systemd also tries to be the central logging engine for your system, and it stores those logs in a binary format. Again, we remember the system philosophy, everything is text, but with kernel control, which is the log management tool for systemd, there are actually benefits to using binary format, because then you can do the output of the log. You can do a local output of times. You can do time zones with the log files and do other stuff. So it's not all bad. Try to get a handle of it. Take a look at it. Question to the audience. How do you know that a Windows administrator is working on a Linux box? He's looking for the GUI. That's one option. Yes. Actually, usually, if you do not work, he's still using NSLOOKUP. So if you grab for your shell history and find NSLOOKUP, you know that the passwords are too easy and you have to change them because the Windows administrator guessed them. So the new tool to use would be dig. It does NSLOOKUPs. It basically does anything that DNS lookups. It does everything that NSLOOKUP does, but I think in a more interesting or nice way. So if you do dig, this is, of course, again, Unix philosophy, easy to parse output, stripped down to the bare necessities and no extra information. Let's dig into this. So if you do a dig on the Balcon URL hostname, you get some basic information. Oh yes, I just ran dig. Thank you very much for that information. And I ran dig on this hostname. I got an answer. Awesome. I get a few informations I got one answer, which is awesome. I did one query. Okay, thank you very much. Oh, you're repeating the question again. This is awesome. Thank you very much, dear dig. And I get my answer. Yes, finally. And of course, this took 48 milliseconds. I did it on my local machine and did it just a few seconds ago. Awesome. So again, this is not really what we want from a Unix tool. Fortunately, there's an option called +short, which will give us the answer that we were actually looking for. And fortunately for you, You can set this option in a config file in /etc, so you don't have to specify it every time. And then dig is actually a very, very useful and very, very simple to use tool once you configured it properly. So let's compare NSLOOKUP, of course, again, against the Balkan hostname, web server hostname, with dig. The same, of course, goes for an MX, for the mail exchanger. With NSLOOKUP, you did -q equals MX. With dig, you just add the MX at the end and get the answer as well. So again, this is just a simple thing. If you're still using NSLOOKUP, try to train yourself to use dig. That's the way the cool kids do it in 2018 and 19. Another nice tool that's actually rather old is TracePath. It's a user-space version of Traceroute or Traceroute. Pick your pronunciation. The nice thing about TracePath is it can calculate the path MTU. So if you ping a certain host, you get the maximum transfer unit, maximum transmission unit you can use on that path, especially in a local network. That's quite nice because you can then optimize your network package sizes. So let me try to show you this. So you got your interface, I got mine, and let's take a look at, no, that's not what I wanted to show you. Okay, I don't have a trace path for, yeah, I don't have a demo for that, but I have a screenshot of that. So you basically do a trace path on a certain host, and on the right-hand side, top line, you see the path MTU of 1,500, so you can optimize this, which is nice. What I actually wanted to demo is MTR, or my traceroute.